Good morning. Today during our Google Meet, some of the students said they were having a hard time with their computer and they missed the explanation on how to do the speed calculations on page 10, and then it will also carry into page 11 of the textbook. So I am going to post our explanation of how you need to show your work when you're calculating speed, in case you need to review this from today. So the speed equation says to calculate the speed of an object, divide the distance the object travels by the amount of time it takes to travel the distance. And we saw that you can write it out using words. Speed equals distance divided by time. To abbreviate this, speed is actually abbreviated with a V for velocity so that we don't confuse an S with seconds, which is a time, like meters per second. So these two things mean the same. If you see them, you would read them the same way. Speed equals distance divided by time. In the sample problems that we did together in the book, we have this story problem involving two triathletes. A triathlete runs a race that includes 3 different types of activities. In the first part of the activity, the first leg of the race, they are swimming. So the total distance the athletes travel is going to be 3 kilometers. Triathlete A's time is 0.8 hours. Triathlete B's time is 1 hour. So that means it took triathlete A 0.8 hours to travel 3 kilometers. It took triathlete B 1 hour to travel 3 kilometers. So we want to know what their average speed is for the whole race. So we know the total time, we know the total distance, we can divide them. When you do these kinds of problems in science, you have to show your work. And what that means is you begin by writing down the formula or equation that you're planning on using to do the math. And this way, if you get the wrong answer, we know where you went wrong. You are welcome to use a calculator. In fact, I encourage it. However, you need to know what to type into the calculator. So that's where writing down these steps can help you. So for triathlete A, we're going to substitute the variable d distance for the actual distance, which is 3.0 kilometers. You can't just write 3. You need to bring all of this information into the problem, including the units. The units are very important, okay? It says triathlete A's total time is 0.8 hours. So in the calculator, you would type this in, and sometimes when you use a calculator, you get what looks like a phone number, a number, point, a number. We don't need your phone number. We don't need all those numbers. You can round your answer to the tenths or hundredths place, but I would not go any farther than 2 numbers past the decimal. So in this case, if we round to the tenths place, we get 3.8. Okay, so I have typed into my calculator 3 divided by 0.8. So that's the other benefit of writing it out this way. It shows you the order you type it into the calculator, and it does make a difference. If you were to flip these numbers around, you'd get something else, right? So 3.8 what? Well, kilometers and hours don't cancel out. You need to keep them. So kilometers per hour. So triathlete A was traveling at 3.8 kilometers per hour. Triathlete B, same thing. We start with our formula. We substitute the variables, distance for the actual distance, time for their actual time, and then 3 divided by 1 is 3.0 kilometers per hour. So one of the questions you might be asked is who's traveling faster? If we compare these, who is covering more distance in that hour worth of time? This person is covering 3.8 kilometers. This person's only going 3 kilometers. We're not really familiar with kilometers.